911, what's your emergency?
Yeah, I'm hiking on this mountain. I think it's Wasatch Mountain. It's been a few hours now. I'm getting lightheaded. I really don't think I can make it back down on my own.
Can you tell me what direction you came from, sir?
I went up on 22nd Street, I think.
Okay, stay with me. Help is on the way.
Drones are being deployed in burnt-out areas to help rescue animals who now have nowhere to go.
WA Police trialling new drone technology to help catch criminals.
Just last week, officers used a drone to track an alleged drug runner on an e-scooter.
A drone helping to find the wayward Kelpie puppy. Her owners even scaling a cliff face to be reunited with their beloved pooch.
Once considered as nothing more than a toy, drones are changing the way armies fight, how beaches are kept safe, even transforming how farms operate. Now, there's a new degree on offer in Sydney to train future drone pilots for an industry that's showing unprecedented.
Drones are transforming the way we solve problems across industries, from wildfire surveillance to sea rescue to shark detection along coastlines, and even food and medical delivery in remote areas. While drones are capable, they still heavily depend on manual control or preset GPS routes. That's a big limitation, especially in dynamic or unstructured environments where human guidance is not possible. That's the problem we set out to solve. In this project, we designed an automated drone system powered by AI computer vision algorithms. Instead of relying on external instructions, our drone can understand its environment through its camera, using segmentation to find flyable paths and object detection to locate safe landing zones. It's a step toward truly autonomous drones that can think and adapt, even in unfamiliar GPS-denied environments like forests or indoor rescue missions. Let us show you how it works. Once the drone takes off, it first ascends to stabilize its flight and prepare for visual processing. It then lowers its altitude to begin analyzing the ground. At this stage, the drone enters segmentation mode, using AI-based image segmentation to detect and highlight flyable paths. It calculates the center of this path to determine a safe and accurate flight direction. As the drone progresses and the landing pad comes into view, it automatically switches to detection mode. Now, instead of following the path, it focuses on the landing pad, continuously adjusting its position and altitude to approach the target smoothly. Just before landing, the drone slightly increases its height to help the downward-facing positioning system clearly capture the pad. Once aligned, it activates the built-in landing function and safely descends. This demo showcases the full workflow in action, performed in a controlled indoor environment using a U-shaped net corridor. The goal was to simulate a realistic indoor path with turns and a visually guided landing. Our system was trained using YWELL V8 for both path segmentation and landing pad detection, enabling the drone to visually interpret its surroundings without GPS or manual control. We also developed a custom graphical interface that displays real-time video feeds, segmentation and detection overlays, drone status indicators like battery and altitude, and control buttons for takeoff, landing, and mission switching. Together, this creates a fully automated drone system capable of understanding its environment, making intelligent flight decisions, and executing a safe and precise landing, all driven by computer vision. Thank you for watching. We are Team Alpha.